Finally, what we want to do is we want to be able to look at some cases where they're elastic. So again, I've switched them around so that we've got them bouncy, so the magnets are hooked together. But we want to look at what happens if we have different masses colliding. Now these we won't be able to solve mathematically, but it is interesting to watch them and see what happens. So what do we think will happen? So before we had equal masses, we had one at rest and one not moving. So let's keep the small one at rest, and this is the heavy one. So if the small one is at rest and the big one moves in and collides with it, what will happen? It will transfer its momentum. But since this one has more mass, it's going to have more momentum. It's going to have a lot of momentum. And so when it collides, notice what happens. It keeps going, right? It doesn't stop right away. So it gives a lot of momentum to the small cart, but it doesn't give all of its momentum because the small cart leaves before all of that momentum can transfer. You can also notice the velocity difference. So watch what happens to the velocity of the small cart compared to the velocity of the big cart. The big cart comes in with a certain velocity, and the little car shoots out faster than that. So the big cart has momentum and it gives a bunch of momentum to the little cart. It can't give it all because the cart leaves, so the big cart keeps some momentum. And the little cart, because it has such a small velocity, such a small mass, its velocity can be much higher. Let's do it the other way now. Let's see what happens if the small cart collides with the big cart. Do we think it'll be the same thing, that it gives momentum to the big cart, or do we think that it will be a little bit different and it'll say, oh, it can't transfer all its momentum, or it's going to go faster, or it's going to go slower? So be real thoughtful about this. Make a prediction about what you think is going to happen here. Are you making a prediction? Here, let me help you. Can you see that? We're trying to make a prediction what happens if a small car collides with a big car and they bounce off of each other. All right. Pause the video if you're not done with your prediction. Otherwise, we're going to go ahead. So the small car is going to come in. The big car is going to be at rest. Notice what happens. Car comes in. Uh-oh, what did you notice? Was that consistent with your prediction? Big car is at rest. What did the small car do? It obviously transferred some momentum to the big car. But notice what happened. Did it transfer all of its momentum? Let's do it again. Transfers momentum, the car leaves, but notice this car, the small car, moves backwards. So in fact, what happened is the small car transferred its momentum to the big car, and the big car left. It transferred so much momentum, it transferred more momentum than it even had. And so it had to have negative momentum because it moved backwards and it had a negative velocity. It transferred more than it had to get that big car moving, and it bounced off of that car. So it ended up having negative momentum so that the big car could have enough momentum to move away. I don't know about you, but I think that's really strange that it could give up more momentum than it had in order to cause that collision to work, but apparently that's the way it goes. In these cases, we can't really solve these simply. Part of the problem is if we draw our pictures, here's a car, 2 kilograms, here's another car, 4 kilograms. Let's say that this one is velocity of 0 and a velocity of 10 meters per second moving that way. After the collision, what do we have? Well, we have 2 kilogram car and we have 4 kilogram car, but 4 kilogram car is moving this direction with some unknown velocity. 2 kilogram car is moving this direction with some different unknown velocity. Velocity 1, velocity 2. I have two things that I don't know. So in order to solve this equation, this problem, to find out what are these two velocities, if I have two unknowns, I need two equations. My conservation of momentum only gives me one equation. So I won't be able to solve these completely with only momentum. It turns out that in order to solve these, you would need to use conservation of momentum and conservation of energy. If you use conservation of momentum and conservation of energy, you get two equations, and you would be able to solve this completely to know both of these velocities. But at the very least, you should be able to tell me, do you expect the velocity 2 to be positive or negative? However you solve it, you expect it to be positive because we know and we saw that it moves to the right. And velocity 1 we expect to be negative because we saw that it moves to the left. So even without being able to solve them, we know some basic things about what we expect when if we did solve this using those equations.